Boom. Let's talk about design exercises from class today. So what did we do? Well, we discussed the exercises that you did for class today, both in small groups and as a class, and what did we learn by doing that? Well, we recorded our discussion as a class, and we learned that Google Meet video recordings are terrible. It's just a video of the person's head, so it's like imagine my head in the corner, but for the entire screen. And all of the chat, there was like a lively chat going. You get that as a text file, so you have to like look at the timestamps in this text file and figure out where that goes in the video. It's not nearly as good as Google Meet Live. Also, we learned that breakout rooms, if we're going to try to do breakout rooms for discussion, Spacco needs to send that stuff out ahead of time. I need to send it to the group leaders. Well, I need to have group leaders, send it out to the group leaders, have them do the invites. Also, we learned that when you do set up a breakout room and send an invite, you've got to post the group invite to Slack, not just to Google Meet, because if you disconnect and reconnect to Google Meet, it actually clears your chat history. Also, if you join the main class late and your breakout room's already started, you can't see chat from before you were there, so that's not going to work. Overall feedback on these design exercises, these are actually really difficult. So there's a huge difference between reading a problem and saying, hey, I'm going to use a hash set to solve that, and then actually sitting down and sort of designing the right structures such that that hash set is able to solve the problem that you needed to solve. Also keep in mind that each of these problems was written by a CS142 student, possibly people who are currently in the class. So often the descriptions will contain these like implicit assumptions that you as a developer might not know. Now, this is really common in the software world where, the client is usually not a software developer. They're hiring you to write software for them. So they have assumptions about the problem domain. And part of your job as a developer is having mechanisms and structures and systems to get that feedback out of people, to get people to tell you what they actually want, what they're trying to get done. And so that's where agile methodologies, where you have a lot of feedback that you're getting from the client, constant meetings with the clients, that's where that gets really important. So, these are just down at the bottom here. These are just some of the possibilities, VIP passengers and flight staff apparently had the same priority for number 3, although it wasn't entirely clear. Maybe that was an assumption. Also, Gloomhaven initiative changes every round. I didn't know that. I assumed it was like standard D&D where you just have the same initiative every round. Who knows? So some highlights of the week. Our winners of Slack were Yaman and Charles for their excellent thread on learning how to iterate over a map. And our epic bug of the week was DK, who had a multi-hour long debugging session of what turned out to be an aliasing issue. So this was Yaman's original code. Basically, the type of this variable plans is a map from string to a list of strings. And what we want to do is count, go through the entire thing and figure out like, okay, how big is all of this stuff combined? So here's one way to do it. We take the keys, we make an iterator, we have this like while loop here. So while we have more stuff, we're going to take plans, we're going to do a get on whatever the next key is. So that's going to get us back a list, and then we'll just take its size and add that to total. This works, but it's kind of, and Yaman kind of knew this, like this is not the most elegant way to do this. There must be a better way, and so there is. This is the final code, or at least this is sort of where it was headed. I don't think it exactly looked like this, and I've made some simplifications anyway, but the idea here, like, okay, I can take a map and call this values method, which just gives me back a collection of the values. What type is that collection? Is it a list? Is it a set? It actually doesn't matter. It's just a collection is just a thing I can iterate over. And so here we're like, okay, this is a list. So now we have a collection of lists. So I can iterate over this. And then what can I do with the list? Well, I can get its size and then add it to total here, right? So this is a more elegant way to do this. It's clear what you're doing. It's also using a for each loop, which is always better than using a while loop with an iterator. Don't use iterators directly unless you absolutely have to, unless there's no way to do it with a for each loop. You should always use for each loops whenever possible. This was DK's epic bug. This was awesome. So this actually doesn't work. So here we've got this array for stats. We're like reading, stats 3 at a time out of a text file. Here we're iterating through this text file. So while we have more inputs, and we know the text file is going to have basically 4 values, a username, and then 3 stats, right? And so what we're trying to do is get the username, put the stats into an array, 0, 1, 2 into this array, and then put that into a hash map. Here's the problem, though. There's only ever one array because we create the array outside the loop, right? So we create this array once. Yeah, we replace the values a bunch of times, but what do we put in here? We put the username and the stats, right? So we're going to have all these different usernames, Bob, Joe, Alicia, DeAndre, whatever, Carlos. I have like some name for most letters of the alphabet at this point. Right, so they would be mapping to stats, but they're all mapping to the same array. Yeah, we changed the values a bunch of times, so what's going to end up happening is every username is mapped to the same array, right? And whatever the last three values we happen to read are just what's going to be sitting in there. So that's not really, what we want. Now, this is a challenge you always have with references. You can have aliases, right? We have multiple names for the same thing. So, I spent time on this, like, I've made this error, I don't even know how many times, and I did it just a couple of years ago when I was messing around with trying to re-implement Boggle, and I guess this is probably in Python, not Java, but Python has references, same problem, and it was like, I passed the same visited set to all the recursive function calls, and I was like, wow, that's really weird, I'm only finding 3 words in this whole Boggle board, there should be more than that. And I'm so bad at Boggle, like I was like, oh, 3, I guess that's just a really tough board. And of course I was off. There were actually 150 or something. I just was making this error because it's such a common error. So if you haven't made this error, you will. And if you've already made this error, congratulations, you've also had your epic bug, but keep it in mind. So how do we fix this? Well, here's how we fix this. We don't create this outside the loop. We create it inside the loop. So each time through, we create a new array, right? We're calling a constructor inside the loop. So we have a new array. And then we, read these values into it. And then we put this into our hash, username mapping to this. And that's great, right? So we don't do it here. We do it here. That's going to fix the problem. So this was literally just like the code was all correct. Just had to copy paste this from here to here. Boom, fix the problem. Not to brag, but I totally knew that was what it was almost certainly going to be, because I've seen this. Like, students make this error all the time, multiple students a year. I've made this error. Everybody makes this error. Like, you just know this error is coming. If you haven't made an error like this, like you will. Like, just wait, it's coming. Okay, so I don't have a drawing pad set up yet. So I wanted to draw the memory diagram, but I didn't. But I did sort of turn this into a REPL. And basically, to prove that it's the same array every time, I went and printed out the hash code. And it's true that identical objects always have identical hash codes, but it's possible for different objects to have the same hash code. You could tinker with the code and call the equals method on any pair of those values that are in that map. It's all the same array every single time. Okay. So here's a note about the way collections work in Java. There's this interface called collection, and they're generic, so it can be a collection of T, where T is just the generic type. It works for any possible type. And what do you know about a collection? Well, you can ask if it contains a T, you can add a T or remove a T, and you can iterate over the T's. And that's all you need to know that it's a collection. Now, what's really interesting about this is that's true for both sets, which can't contain duplicates and are not ordered, and lists, which can contain duplicates and are ordered. Both of those, you can ask if it contains something, you can add something, you can remove something, and you can iterate, right? Iterating over a list, it's ordered. Lists are ordered. Iterating over a set, it's unordered. It's just whatever order the hash code happened to stick things into the underlying, probably array, you don't really know. Contains on a set, depending on the kind of set, hash set's going to be big O of 1, amortized. Tree set's going to be log n. List is going to be order n, because you have to check everything. And then, of course, you've got linked lists and array lists. So this is kind of what your hierarchy looks like. So whenever possible, if all you need to be able to do is check if it contains something, to a method or something like that, don't say set or list, just go with collection, and that's totally fine. If you only need these 4 things, you can just say that's a collection. So that's one thing to keep in mind. Just a quick review. Remember, set means no duplicates. And there's multiple implementations of set. Set's an interface. But the 2 most common ones are hash set. So for hash set, add, remove, and contains is big O of 1 amortized, assuming you have a decent hash code method. And the elements are not ordered in a useful way. It's essentially unordered. You can iterate through it, but who knows what order it's going to come out. And then tree set, add, remove, and contains is log n. It's basically a binary search tree. And the elements are sorted by their natural order. So that means that the elements have to implement the comparable interface. We'll talk about how to implement comparable interface. It basically means it's an interface that lets you declare like, hey, this thing is sortable. And it just gives you essentially like a less than operator, a greater than or less than operator, so that given two instances of the same class, it can figure out what order to put them in. So it makes it sortable. And essentially, tree set is an implementation of some kind of rebalancing binary search tree that you learned about in 142. I'm pretty sure it's a red-black tree, not an AVL tree. You can look that up in the Java API if you want. I'm like fairly certain it's a red-black tree. Okay, so map, which is not a collection, and the reason being collections just have elements. So lists have a single type in them. Sets have a single type in them. Maps have two different types, a key and a value. So you can't really fit these into collections, right? A map is not a collection. But there's two major implementations. There's a hash map and a tree map. So a hash map, put and get, are big O of 1. But the keys, again, are unordered because the keys essentially form a set. Tree map, this is essentially a binary search tree, but with maps, you have both keys and values. So for a tree map, put and get are log n, again, log n on the keys. But the keys are sorted by the natural order, which once again mean the keys have to implement that comparable interface. Okay, and remember with linked list and ArrayList, there's trade-offs. These are both lists, which means they're ordered, and there's things you can do to a list that you can't do to a set, like you can get things at a certain index. It makes sense with a list to say, get me the element at index 3. It doesn't make sense with a set to say, get me the element at index 3. There is no index 3. Sets are not ordered. So what to remember about linked list and ArrayList? Well, ArrayList is big O of 1. It's constant time to access elements in the middle because ArrayList, as the name implies, are backed by an array. Linked list, it's big O of n to get something in the middle because you have to like get that little temp thing and bump the temp pointer along until you get to the right location. There's no better way to do that for a linked list. Linked list is big O of 1 to add to the front or to the back because the standard implementation of a linked list will have both a head and a tail pointer. And linked list in Java is a doubly linked list, so you can go in both directions. ArrayList is going to be big O of n for at least one of those operations, right? So adding to the end of an ArrayList is probably okay until you have to resize, so it's amortized big O of 1. But adding to the beginning, you have to shift everything down. You're going to have to do that for one or the other. And for the way ArrayList is implemented in Java, you can add to the end big O of 1 amortized. Amortized meaning occasionally you have to resize. But to insert at the beginning, it's big O of n. You have to shift everything down. Right, so there's trade-offs between these. There's not one perfect structure. It depends on what the problem requires. So you have to look at the problem very carefully, and you may need to ask clarifying questions. Why is this important to know about asking these clarifying questions? Well, if you're doing interviews for jobs, right, online tech interviews, these are some of the clarifying questions to ask. If you read the problem description, you're not sure, or maybe there's not enough information, or maybe there is enough information, you want to confirm, ask these kinds of questions. Asking these questions makes you seem smart because it shows that you really understand the nuances of linked lists and array lists. You're not just like, oh yeah, there's some nodes and maybe there's an array and I kind of vaguely wrote some code and got some credit for that when I was a student. No, you got to know the nuances of this stuff to really understand what's going on. And so, your conclusions, linked list is great for queues. Array list, great. We need to access elements in the middle by an index. Okay. Use classes for flexibility. So especially if you're right at a 142, you'll often want to write things like this. So you'll be like, okay, I've got a map from a string to a list of strings. I saw this a lot with these design exercises. People were like, I know about maps, I know about lists, I've got a map from string to list of strings. So imagine like this is the name of the album and this is a list of the song titles on the album, right? So, imagine that's the situation. Well, if that's the case, don't make this a list of string. Make it an album class, and then encapsulate that list of strings instead. So now we have a map from string to album. Why is that better? Well, here's what that would look like. So we got a class album. We've encapsulated that list of string. And again, here, should it be an array list? Should it be a linked list? I'm not really sure. I'm just going to say list of string for the variable type. And then I'm going to initialize it as an array list because maybe I want to get get me the fourth track, get me the eighth track. I realize this makes no sense to all of you millennials because you're like, I thought music just showed up on Spotify. Like, why would anyone buy an album? I don't know. Talk to your, older siblings or parents or something like that. So, and then for, add title, add a song title, you would just these, and get by the index, these just delegate down to the list that we've encapsulated. Maybe we need to add some other methods, who knows? And if we suddenly decide, what, I actually just only need a linked list, we can then just change this here. This doesn't need to change, which means all the uses of this don't need to change, because if we make it a list of titles, then we, by definition, can't use titles in a way that will only work with ArrayList or LinkedList, right? If we sort of do it this way over here, we can swap in anything we want over here. Now, why is this better? Well, think about this. What if the next version of the code, right, before we just needed the song titles, now we need the release date of the album? Well, if we got the first situation, right, we've got a map from string to a list of strings, where do we put the release date? Do we just make like another map from string to release dates or something and then just like sort of remember that they're related? We could do that, but it's ugly. This is really obvious. Okay, album is a concept. It's a object-oriented systems or object-oriented class. So like it encapsulates a list of songs, but if there's any other information about an album we need, we just stick it in this class. So as an object-oriented system designer, you should write lots of small, stupid classes that just encapsulate data in often very uninteresting ways. So all the data structures you built in 142, list and linked list and array list, and you learned about binary search trees and things like that, those are awesome data structures, but the vast majority of object-oriented modeling you're going to do is much stupider. It's like, I need a student ID, or a notion of student in the registrar system. So we have like a, string for the first name and a string for the last name and, some other class for the address, and we have, an ID number, which should also be a string, and this, that, and the other thing, but those are not, there's not, it's not complicated. But it does need to make sense conceptually, right? So, you're much better off creating a class that encapsulates a list and just directly using the list, right? That's not thinking at a very high level, and it's not giving yourself flexibility to change when requirements change. And, software's never done in version 1. I mean, it is when you're a student, which is like bizarro world, but in any actual situation, software's not done with version 1. You need a version 2, version 3, the client changes their demands, the market changes what you need to do, so on and so forth. Okay, I just wanted to note from my sort of Twitch stream from last week, design problem number 10, I actually did exactly this. I was trying to figure out, criminal history, like you either had to have no criminal history or all of your criminal things had to be explained. So I had this class for criminal record, and you could ask if it was explained away, meaning like, it was a misdemeanor or, the State Department had flagged it as okay, I don't know, whatever. So I wrote this criminal history class, which just encapsulates this list and had a couple of really simple methods. And what this means is that from the Customs and Border Patrol class, this is for design exercise number 10, we're mapping passports to criminal histories, right? Customs and Border Patrol, given a passport, can say, let me look up the criminal history. Now, I could have made this list of criminal records of like particular crimes, but maybe there's meta information about criminal history. Maybe we need to have data about, who's the most recent person to review the case file or something like that. If this were a list of criminal record, to go back a slide, kind of like it is here, there'd be no easy way to do that. But by making this class and just real quick encapsulating this and then writing like an add method that just sort of delegates down to the underlying list, I've given myself a level of indirection, a place to put new requirements as they emerge. If I didn't do it this way, I couldn't do that. Cool. And then here, this has clean background, which is like, here's a passport. It's just delegating the call down to the history. It's saying like, okay, either the history doesn't have this, or, I have it, but everything's explained. If either of those are true, go ahead and return true. You got a clean background. Otherwise, return false. Okay, moving on. Last thing, don't catch exceptions. I don't have an example. We'll talk about this again in the future. But general rule, never catch an exception unless you can recover from the error, right? So, if you get an IO exception, can you recover from that? Maybe you can, maybe you can't. But if you can't, if you don't have a clear way, like, I tried to open a file, it failed. Well, unless it's like a GUI application where the user specified the file name and you want to print an error message for them and prompt them to, use the file chooser to find a file again or something like that, then don't catch that exception. You can't fix it, right? If it's your code, especially, and you like mistyped the file name or you had the path wrong or something, why are you catching the exception? Like, don't catch the exception. So just throw the exception out of the method, right? And if the method calling that also doesn't know how to recover from there, throw it out of that too. And if you have to just have it throw all the way out of main, that's also fine. Also, just I think checked exceptions are stupid anyways. Java has them. Some exceptions are just runtime exceptions, like null pointer exception, array index out of bounds. They can just happen at any time. Some exceptions, like IO exception and file not found exception, and I don't know, parse exception for XML parsers or something. Those are checked exceptions. Why? I think checked exceptions are probably a bad idea and don't really make any sense. But Java has them, so you kind of got to know what to do with them. Easiest thing, just never catch an exception unless you're like really confident that you can fix that situation. If you don't know how to fix that situation, just don't worry about catching the exception. Just throw it all the way, and if you throw it to main and main crashes, that's fine, because guess what happens when main crashes with an exception? It prints out a stack trace and an error message. Well, what most people do, most students especially, when you see a try-catch block, you catch the exception and you just do like e.print stack trace or something like that, or you do, system.out.print line e.get message or something like that. Well, that's just printing the error message. But it's actually really bad because it's also continuing on. This is more information than I meant to give. I'm just saying don't catch exceptions unless you know what to do with it. Moving on. These are the design exercises. I might take these on in the next stream. I'm actually too tired because it's after midnight already to really, really dig into this. So I might just sort of crunch through these on my next stream. Great. How do I stop this?